Ladies and gentlemen, good evening. It's my great pleasure and honor as President of the Royal Academy of Engineering to welcome you to this evening's Academy's second International Lecture. The International Lecture was created following a generous donation from the ERA Foundation to enable a United Kingdom audience to hear an international perspective from an eminent person with broad engineering interests. With the whole world to choose from, selecting a suitable speaker for the International Lecture isn't always an easy task. But tonight it is. I am delighted, and I believe I am honored, that my friend and colleague, Dr. Pachauri, Chairman of the Intergovernmental Panel on Climate Change, accepted our invitation to deliver this year's lecture. It's my personal pleasure to introduce him. I've known him for some time. As chairman of the IPCC, the world's foremost authority on climate change, Pachi has had a unique insight into the global challenge that we face to mitigate and adapt to climate change. Not many people are aware of the fact that Dr. Pachauri is in fact an engineer by training. This is perhaps because he has the unusual distinction of having doctorates in both industrial engineering and economics. Some might argue why you needed both. Dr. Pachauri's distinguished career has spanned the academy and industry. In addition to chairing the IPCC, he's Director General of the Energy and Resources Institute, TERI, a not-for-profit scientific and policy research organization based in New Delhi, which fosters the development of solutions to global problems in the fields of energy, environment, and sustainability. Dr. Pachauri's expertise has led to numerous appointments to advisory boards and committees. He's been President and Chairman of the International Association for Energy Economics, President of the Asian Energy Institute, and a member of the Economic Advisory Council to the Prime Minister of India and the Indian National Environmental Council. Dr. Pachauri has also written more than 20 books and is published widely. His immense contributions to the field of energy and the environment have been recognized through many honors, both Indian and international, including the Padma Bhushan, one of India's highest civilian awards, and the French Légion d'honneur. The theme of climate change and energy is one of my personal priorities for my term of office as President of this Academy. The Academy is working with the UK's leading engineering institutions, in all representing some 250,000 chartered engineers, and has established a committee on energy and climate change, and experts on that committee to deliver independent advice to government on the technologies and actions needed in the UK to reduce greenhouse gases from energy use in the shortest possible time. This lecture provides a timely opportunity for us to reflect on the global context of this work and to hear a personal perspective from one of the leading experts in this crucial field. Pachi, welcome.
Lord John Brown, distinguished ladies and gentlemen, it's indeed a unique honor that I've been asked to deliver this second extremely important lecture in a series I'm sure, except for mine, will have a major impact. It's an even bigger honor to be invited by Lord Brown, someone who, as he mentioned, I've had the privilege of knowing for some time, and more than that, someone who I've admired for a much longer time. One of the things that I normally do, but I'll omit today, is to quote him extensively, because in most of my presentations I do refer to things that he has said. But what is even more important is what he has done. He is really a unique leader who has brought together the interests of business and industry with the interests of society. And that takes vision, takes a great deal of courage, and I remain and will always be a great admirer and will continue to see the important contributions that he would be making, I'm sure, throughout his career. So thank you very much, John, for inviting me to this important occasion. I'll start by giving you a brief overview of what the IPCC is and what its impact has been. And in keeping with the title of this talk, I want to emphasize an important aspect of the work of the IPCC, and that's essentially its role in helping to devise actions and policies that hopefully are based on knowledge that is created by outstanding scientific endeavor. And climate change shows how science can help address the work of the IPCC shows how science can help address problems facing humanity. And that's essentially through creating knowledge and understanding on a complex area of interrelationships between human actions and the environment. And of course, through defining specific solutions that can address the problem if applied on a large scale. I believe that the role of scientists in not only articulating the major challenges and problems that humanity faces, but in also being able to assess a range of options is something that you'll see much more of in the future. And this is also a function of the transition that has taken place in the role of scientists and technologists. There was a time when they were regarded as a fringe group, albeit a very important group, but their work was not always subjected to the kind of scrutiny that society demands today. And as a result, the IPCC, which I might say by its very nature and the processes that it follows, functions in a very transparent manner, and therefore it's able to discharge its responsibility and establish accountability to society through the various methods that it follows. I'm going to touch on some of the major findings of the fourth assessment report, and I'd like to mention that we have completed 3 volumes of the work of the fourth assessment report. These are 3 working group reports. The first deals with the physical scientific basis of climate change. The second, which is working group 2, deals with impacts of climate change, vulnerability, and adaptation to climate change. And the third deals with mitigation options. We are now in the process of completing and hope to release what is known as the synthesis report, which by definition is a synthesis of the knowledge contained in the 3 working group reports. And if I was to look at some of the major findings of the 3 working group reports that have already been completed, you would see the first part projected on the screen, which clearly shows the changes in global mean temperature that have taken place since the beginning of industrialization. And what's particularly important, and therefore to some extent worrisome, is the acceleration of change that has taken place. If you look at the slope of this plot that you see over here, in recent years this has certainly become steeper. And this is essentially because there's been a substantial increase in the concentration of greenhouse gases in the Earth's atmosphere and the extent of emissions that are taking place on an annual basis. Some of the numbers are mentioned over here in terms of the period and the rate at which changes have taken place. And you can see that in the last 50 years, the rate has been much higher than the rate that applies to the entire previous 100 years. And we have come to the conclusion that warming of the climate is unequivocal, and this is based on observations which have been analyzed. And we're now fortunate to have much more extensive and very much more reliable observations than was the case, let's say, at the time when the third assessment report was completed. And if I was to show you the changes that have taken place, you see a plot over here of global average temperature, which, as indicated earlier, has changed significantly in the period since 1850. The second picture relates to global average sea level, and here let me give you some figures. As far as average temperature increase is concerned, during the 20th century, our estimate is that the increase has been about 0.74 degrees centigrade. And this, incidentally, is higher than what we had estimated in the third assessment report, which amounted to 0.6 degrees centigrade. And that's largely because we have much more extensive observations and much more reliable observations. Sea level rise has gone up during the 20th century by about 17 centimeters, which is significant. And here again, the rate has accelerated in the last 10 to 15 years. And you see in the bottommost picture a reduction in snow cover in the northern hemisphere, which is quite worrisome. And I might mention that I've been to the Arctic region. It's most noticeable in that region. And the Arctic, if I could state, is warming at twice the rate of the rest of the globe. And that clearly has implications not only for the volume of water that would go into the sea and therefore result in sea level rise, but also the fact that this would affect all forms of life in that region. One particular species that is often referred to as being endangered is the polar bear. And you can see not only anecdotal but also observational evidence of how, for instance, polar bears are not able to get seals, which they really thrive and feed on, in their normal habitat, and therefore they're having to move northward at a very rapid rate. And therefore, over a period of time, there's always the danger that this species, apart from others, could be endangered. If we take a paleoclimatic perspective, then the warmth of the last half century is clearly unusual, particularly if we see it in the context of the previous 1300 years. And the last time the polar regions were significantly warmer, and that of course was for an entirely different set of reasons, essentially because of changes in the axis of the Earth and the fact that it came closer to the sun. For an extended period, that was about 125,000 years ago, reductions in polar ice volume led to 4 to 6 meters of sea level rise. Which is not to say that it's going to happen this time around, but we need to clearly keep a focus on what happened the previous time. And of course, there are a number of scientists who are now telling us that there is a real danger of the Greenland ice sheet and the West Antarctic ice sheet collapsing, as a result of which sea level rise could turn out to be disastrously high. What is the human contribution to climate change? We now know that in different regions of the world, there is much stronger evidence of climate change, and the human influence, as we have clearly found in the fourth assessment report, is very likely to be the reason for warming that has taken place in the last 50 years. This, I might say, is an upgrade from what we had found in the third assessment report, where we used the term likely. And the difference between very likely and likely is the difference between 90% plus probability versus about 2/3 probability. So therefore, our knowledge today is much stronger and much more robust, on the basis of which we can make this statement. And you see over here, perhaps from the back, you might not be able to get a clear assessment of what's happening in different regions of the world. But if you look at the bottommost set of pictures, you get a clear indication of changes that have taken place at the global level on the left-hand side, and then changes in global land. And on the right-hand side, you see global ocean temperatures. The reason why the oceans are not warming as rapidly as land surfaces is because it takes a long time for the mixing of the ocean, and therefore this also has a potential hazard or danger or concern, because even if we were to stabilize the concentration of greenhouse gases at today's level and were able to stop, if that were theoretically possible, any increase in temperature, sea level rise will continue for a long period of time purely on account of thermal expansion, because the ocean layers will take a long time to increase their temperature, and as a result thermal expansion will continue for decades, centuries, and possibly a millennium. And therefore, when we think of the conditions of those regions of the world that are most vulnerable to sea level rise, we have to be particularly conscious of what needs to be done to protect those communities and those regions effectively. Another important indicator of the drivers of change is this increase in CO2 that has taken place over a substantial period of time. If you look at what you see over here, we go back in time 10,000 years before 2005, and you can see that the range over there was reasonably well contained, but in recent years there's been a very sharp increase. Those of you who've seen the movie An Inconvenient Truth would probably remember former Vice President Al Gore getting on a platform which goes all the way up to the top of this curve. I must say that was dramatically very, very effective. And clearly, if you had a large-scale diagram of this nature to get to the top of it, you would need some kind of a mechanical device. What's also particularly relevant is the fact that in 2005, the concentration of CO2 exceeded by far the natural range over the last 650,000 years. And this, in a sense, gives you the relative dimension of the interference that we have created with the stability of the Earth's atmosphere. Another extremely important indicator is the impact of climate change on the glacier masses in some regions of the world. And during the 20th century, there's been a widespread retreat of these bodies of ice, and new data confirm that losses from the ice sheets have contributed to sea level rise during the period 1993 to 2003. You see there's been a pretty sharp decline in the size of several of these bodies of ice, and coming from a region where we are particularly dependent on the water flows in our river systems, particularly in the northern part of the subcontinent. I have a personal interest in this issue. As a matter of fact, the institute that I'm responsible for is now going to get into a major study of the glaciers in the Himalayan range, because that's going to affect, as the IPCC has estimated, something like 500 million people living in South Asia and perhaps 250 million people in China. Because initially we might get an increase in flow in these river systems, but over a period of time there would inevitably be a decline, simply because the mass would have reduced substantially. And this has implications not only for water in the rivers, but also in the recharge that would take place in groundwater resources. I should also highlight the fact that while there are changes taking place in average precipitation levels, and here let me mention that generally in temperate regions there is an increase in precipitation and will continue along that path. In the tropical, subtropical and Mediterranean regions there is a decline in precipitation, both snow as well as rainfall. But at the same time there is a significant increase in extreme precipitation events. And I don't want to link any single event to human-induced climate change, but just by way of illustration, you had floods in the UK recently. In the city of Mumbai this year as well as 2 years ago, we had two terrible cloud bursts, as a result of which, particularly 2 years ago, the whole city was paralyzed and several people lost their lives. because while they were returning from work in the evening, they were stuck in this huge quantity of water which just couldn't be drained off. And several people died because of suffocation, particularly those who were not strong enough to open the doors of their cars against the pressure of the water that had accumulated outside. And today we have windows that can't be rolled down mechanically. They're all operated by electricity. And once there were short circuits in the electricity, the movement of the windows became absolutely impossible. I'm only highlighting this because most people say, I mean, there are some people who say, skeptics say that you can adapt your way out of climate change and its impacts. But there's a limit to what you can do, because it's not merely a linear and smooth increase or change in temperature, sea level rise and other variables that's taking place. There is an increase in the frequency as well as the intensity of these so-called extreme events, and some of these would be physically very, very difficult to adapt to in the foreseeable future. Changes in precipitation, we would have more intense and longer droughts. That's already happening. Widespread change in extreme temperature, heat waves we have measured and are projecting will increase both in frequency and intensity. You remember what happened in 2003 in Europe, particularly in France. At the same time, we had a terrible heat wave in a part of India. This year I was amazed to read that in the city of Athens you had temperatures of 47 degrees. So, you know, these are trends, and once again, let me emphasize, I'm not linking any single event to human-induced climate change, but if you look at the trend, if you look at the pattern, the picture is very clear, and of course this has been analyzed, verified, and corroborated by models that have been run to give us some degree of confidence. Increasing intense cyclone activity, and all of this leads to an important question. As you know, negotiations are at an advanced stage in perhaps arriving at an agreement beyond the period 2012, which is at the end of the first commitment period of the Kyoto Protocol. And one important element or concern with regard to how to come up with such an agreement that is suitable and effective is what is contained in Article 2 of the UN Framework Convention on Climate Change. And this article, as you can read over here, essentially states as the ultimate objective of the Convention our ability to prevent a dangerous level of anthropogenic interference with climate change. And this would essentially focus on issues like food security and the ability of ecosystems to be able to rebound once we create a certain level of damage through climate change. And while, of course, defining what is dangerous involves value judgments, science can certainly provide a basis by which the international community can come up with a definition of what would constitute a dangerous level of climate change. And this, I might say, is an issue which is still up in the air. And while, of course, the EU has come up with a 2 degrees centigrade target as the maximum that should be allowed, this is not universally accepted. And there are some who are even questioning whether 2 degrees might be a bit too high, and maybe we should think in terms of something lower, particularly since you can link temperature increases with some of the impacts that are going to be threatening in various ways. Climate change will reduce biodiversity and perturb functioning of most ecosystems and compromise the service that they provide. And it's the poorest communities in the world that derive their livelihoods. And we have Sir Gordon Conway over here, who is responsible for having come up with a definition of sustainable livelihoods. Now, if there are going to be major impacts on ecosystems and the services that they provide to the poor, then that impacts unfavorably on the ability of societies and communities to pursue sustainable livelihoods. We have assessed that 20 to 30% of plant and animal species are at risk of extinction if increases in global average temperature exceed 1.5 to 2.5 degrees centigrade. Now, this is a serious observation that should really make the human race sit up and think and see how we might prevent such an outcome, which could very well take place in the lifetimes of at least the young generation of today. Some ecosystems are highly vulnerable: coral reefs, marine shell organisms, tundra, boreal forests, mountain and Mediterranean regions. And we can also identify, as we have done in the fourth assessment report, some regional impacts that cause concern. Malnutrition could be exacerbated by reduced length of growing season in the Sahelian region. And in some countries, yields from rain-fed agriculture, which is going to be particularly vulnerable given the fact that there are going to be changes in precipitation levels as well as patterns. This could be reduced by up to 50% by 2020 itself. 75 to 250 million people are exposed to increased water stress in 2020 in Africa. That's one projection that we have made. And I think we need to remember that climate change only adds a certain stress to societies where there already are existing stresses. And you know, you're really talking about a marginal impact that could, in a sense, be the last straw on the camel's back. Those societies which are poor, that are afflicted by several other stresses, would now most likely have an additional set of stresses induced by climate change. And we need to be concerned about those. And I have this weakness of quoting from Gandhi, but Gandhi always highlighted in decisions related to development that you must look at the impact on, as he called, the last man, the most underprivileged. And I think in this set of policies that we are discussing for combating climate change, I think we need to have a specific and a very focused concern on the poorest communities in the world, who obviously are going to be the worst sufferers. And food insecurity and loss of livelihood would, of course, also be exacerbated by loss of cultivated land and nursery areas for fisheries, by inundation and coastal erosion in low-lying areas of tropical Asia. We already have evidence in several parts of the world. I can certainly mention research that's being done in India, which shows that climate change is already impacting unfavorably on yields, particularly of wheat, because during the growing cycle, even 1 degree increase in temperature as far as wheat is concerned can have an unfavorable impact on productivity. And over and above that, with more frequent and more severe floods and droughts, there's an added impact on agricultural output that raises questions of food security on a global basis. Coastal settlements are most at risk, and this gives you a picture of some major cities that are located in coastal areas. And we found that mega deltas in Asia are particularly vulnerable. These include cities like Dhaka, Kolkata, Shanghai, and others. And in this picture you would see the red dots indicating those locations which are at extreme risk, those that are at high risk, and the others that are subjected or are likely to be subjected to a medium level risks. So the spread is quite diverse, and there is no region in the world that can feel immune to the dangers of coastal flooding, for instance. All of this means that adaptation is inevitable, and as I mentioned earlier, given the inertia in the system and the fact that even if we were able to stabilize concentration of gases at an acceptable level today, the impacts of climate change will continue for a long period of time. And therefore, the world has no choice but to adapt to climate change, at least up to a certain level. But we also know that adaptation is taking place through a range of practices, and there are societies across the globe who have dealt with the vagaries of natural changes in climate and have come up with coping strategies in response that are quite effective. But what we are doing now is really testing the limits of how much these societies can do. And we would now have to think in terms of some new sets of measures. Adaptation capacity, I might mention, is limited and uneven across and within societies. The poor, even in the richest countries, don't have the capacity to adapt. And I can illustrate that by what happened with, let's say, Hurricane Katrina or Hurricane Rita, where you found that the poorest sections of society in, let's say, the city of New Orleans had no recourse at all to being able to protect themselves and turned out to be the worst sufferers of the damage that took place. And climate change therefore poses new risks that will require new investments in adaptive responses. If you go to the island nation of the Maldives, which is severely threatened by sea level rise, in the capital island of Male, they already have a protective barrier which I think the Japanese funded, and that certainly provides them with some protection. But you can't do that for the entire coastal region of Bangladesh or other parts of the world that are vulnerable. So there's a limit that has to be seen in possibilities for adaptation. Now let me turn to some projections of the future. Where are temperatures likely to end up by the end of this century? We have assessed a number of scenarios which are plausible in terms of technological changes, economic growth, social changes, institutional changes, and we find that at the lower end of these scenarios, we can come up with the best estimate of 1.8 degrees centigrade by the end of the century. At the upper end of the scenarios, if we have vigorous growth and an increase in emissions of greenhouse gases, we are likely to end up with 4 degrees centigrade, and that's the best estimate we have come up with. So therefore, the future really looks something like what's shown in this particular diagram, and there is a large range. But if you look at even the lowermost projection, 1.8 degrees centigrade, combine this with the 0.74 degrees increase that took place during the 20th century, and you're likely to end up with over 2.5 degrees centigrade by the end of this century, over and above the beginning of the 20th century. And I think the world has to decide whether that's acceptable or not. Now, adaptation, of course, is necessary to address impacts resulting from warming, and this is unavoidable due to past emissions, as I said, on account of the inertia in the system. However, adaptation alone cannot cope with all the projected impacts of climate change. And we know that the cost of adaptation and the impacts of climate change will increase as global temperatures increase. So we have to view adaptation measures within this prism of realism, otherwise one could be lulled into a sense of false security that everything would be well if we just adapt to climate change. Therefore, the conclusion is we need a mix of strategies, including adaptation, technological developments, research, as well as mitigation of GHG emissions. Mitigation and adaptation will have to go together, and this will have to be the central core of policy that deals with every aspect of climate change. Now, on the subject of mitigation, let me draw your attention to the first row of figures that is shown in this table. We have assessed a range of stabilization levels at which the concentration of greenhouse gases could be stabilized. If you look at the uppermost row, we've looked at this level of 445 to 490 parts per million of CO2 equivalent. This, if we were to hold stabilization at this level, this would lead to an ultimate equilibrium temperature increase of 2 to 2.4 degrees centigrade, which of course could take place even spilling over into the 22nd century. This is the ultimate level at which we would stabilize. Now this clearly shows, based on the assessment that we've carried out, that you can allow an increase in emissions no later than 2015. Beyond 2015, they will have to decline. And as a matter of fact, if you look at the reductions that would be required to hold equilibrium temperatures at this ceiling, and therefore corresponding levels of concentration as shown in these figures, then by 2050 you would need CO2 emissions to be reduced by 85 to 50% relative to the level in 2000. Now, this I'm mentioning only because the EU has set this 2-degree target. You could very well have much higher levels of warming and much higher levels of concentration of these gases, and that gives you a little more latitude, that gives you a little more time. But I think human society has to decide whether it wants to limit the damage that would take place as a result of inaction by taking suitable mitigation measures, or do we continue with business as usual and allow things to reach a level where the impacts would be quite serious. And it's also true that mitigation efforts have to start early, and if over the next 2 or 3 decades we have adequate mitigation efforts, then these will have a major impact on opportunities to achieve lower stabilization levels in the future. One is often told that the cost of mitigation in terms of job losses, in terms of reduction in economic output, would be crippling to economies across the globe. Now, what we see over here belies this fact, because what we see over here clearly contradicts this fact, because if you look at the lowermost set of numbers over here, 445 to 535 parts per million, as the level at which you are stabilizing these emissions, then you find that the cost in 2030 to the world economy would not exceed 3% of the GDP. And on an annual basis, this would amount to only 0.12% of the GDP each year. Now, this cost really implies that the prosperity that the world would reach in 2030 would perhaps at best be postponed by a few months. And one needs to see whether that's a very high price to pay. And if you look at the next picture, this shows in graphical form GDP without mitigation and how this would increase during the period that I've just mentioned, up to 2030. And if you carried out stringent mitigation, all you would be doing is shifting this growth line very slightly, ever so slightly, that it really is not going to be a major cost to society at all. I won't spend too much time on this, but only to mention to you that in the IPCC Working Group 3 report, we have looked at a whole range of options by which we can reduce emissions, and we have quantified what is possible in each of these sectors. And of course, we have looked at the energy supply industry, we have looked at transportation, we've also looked at what one might be able to do in the household, in commercial buildings, and so on. And the potential is enormous. Now, the range of stabilization levels of GHGs, and this is something that we found after looking at all the portfolio, looking at the technologies that are available, that all you need to do is to deploy existing technologies and a portfolio of these technologies, and those that are expected to be commercialized in coming decades. So the stabilization level that I projected before you can be achieved even with existing technologies. Of course, the good news is that if we were to invest enough in research and development, and I'll say a little more about that, then over a period of time, you would have new technologies, new methods by which, firstly, the cost of mitigation will come down substantially, and the effectiveness of mitigation will go up also on a substantial scale. What are the technological solutions? Energy supply, because this accounts for 26% of greenhouse gas emissions, and we clearly need a shift in supply technologies and the mix of supply options. This includes renewables, of course, and the advanced coal, gas and nuclear technologies, supercritical steam plants, and a whole range of things which I don't have to go into details of. Nuclear fusion could be an answer. CO2 capture and storage could be an important element of the solutions that we apply. And combined heat and power. These are all technologies that are within our reach, except for nuclear fusion perhaps. In the transport sector, which accounts for 26% of world energy use, there's a whole range of possibilities that we have assessed and listed over here. And air traffic is one particular segment that clearly needs attention because it's growing rapidly, and the improvement in air traffic efficiencies as far as energy use is concerned is certainly lagging behind several other sectors of the economy. Rail transport is another area where a shift to rail and of course an improvement in rail technology can make a difference. Buildings are also important because they account for 30% of baseline emissions, or will account for 38% baseline emissions in 2020. And there's a whole range of actions that could be taken to make buildings and the use of energy within them much more efficient. These are listed over here, which I won't go into in detail. But just by way of an example, my institute in India has been at the forefront of working on buildings and coming up with options that are viable and energy efficient. We have a major training complex over there that uses no power from the grid. But just by way of an example, my institute in India has been at the forefront of working on buildings and coming up with options that are viable and energy efficient. We have a major training complex over there that uses no power from the grid. Firstly, through design techniques, we were able to reduce the total demand for energy from something like 280 kilowatts of peak demand for a conventional building down to about 90 kilowatts in this particular building. And all of that is met by a mix of sources. One is of course photovoltaics, a biomass-based gasifier that generates power, and a very interesting but conventional techniques used traditionally in India and in several other parts of the world. If you go 4 meters below the surface of the earth, the temperature is uniform throughout the year. So what we have designed and devised is 4 tunnels through which we blow air that comes into the building space, and that gives you cooling in the summer and heating in the winter. And all you need is the power of a blower to get that air through those tunnels. So you're picking up the thermal characteristics of the earth 4 meters below the earth. And I think engineers, architects and builders really need to apply their minds and innovate in some of these areas, and undoubtedly we'll come up with some fairly dramatic solutions. Efficient appliances and heating and cooling devices, of course, that's unexceptionable. Agriculture is also an area where technological solutions would certainly reduce emissions from agriculture. And in this respect, I might also highlight the importance of efficient water management, given the fact that the world is going to find some serious spots, some spots where there are serious problems with water supply. We'll necessarily have to move to a totally different system of management of water resources and the use of technologies that are efficient in the use of water, particularly in agriculture. Because several countries in the world use 80% of their water supply for agriculture alone. And these are some other solutions that I'd like to bring to your attention because both livestock as well as agriculture do contribute to greenhouse gas emissions. In the case of bioenergy, of course, energy crops, solid, liquid, biogas, residues, all of these are important solutions. But there is one important question that we need to ask when we deal with the issue of bioenergy and particularly supply of biofuels. We necessarily have to see that there is no competition with food crops. And today, I think there's a lot of criticism of some of the policies that are being pursued in some parts of the world, where essentially land which is traditionally been used for producing agricultural crops is being diverted to biofuels. And there's the, of course, added problem of fertilizer use and therefore greenhouse gas emissions resulting from the use of fertilizers and chemicals. We've assessed a number of national policies and these include providing incentives for the development, acquisition, deployment and diffusion of technologies. That's absolutely critical because merely developing technologies is not going to help. You need a policy framework within which these will be deployed and utilized effectively. Information and education is essential, and we've also highlighted the importance of lifestyle and behavior changes because unless one brings about a shift in values, it's unlikely that purely technological solutions will give us the answers that we're looking for. And one critical element that is missing in current policies is an effective carbon price because this would provide a signal and create incentives for producers and consumers to significantly invest in low GHG products, technologies and processes. Now, you find several leaders telling you that technology is the answer. Merely developing these technologies at the level of the lab or in factories or wherever is not going to be adequate unless it's supported by a system that places a price on carbon because consumers and producers are obviously not going to change their patterns of behavior both in terms of production and consumption unless there is a market inducement to move to low carbon technologies. And therefore a price on carbon is absolutely crucial to bring about change. I end most of my talks with a quote from Mahatma Gandhi, and he rightly said a technological society has two choices. First, it can wait until catastrophic failures expose systemic deficiencies, distortion, and self-deceptions. Secondly, a culture can provide social checks and balances to correct for systemic distortion prior to catastrophic failures. Now, talking to a distinguished group of technologists and engineers, may I say that, as Lord Brown indicated initially, I started my career as an engineer. And I think the power that this profession possesses in bringing about change and ensuring that solutions are devised that would really help solve the problem and this major challenge that society is facing. I can say that there are several steps that need to be taken. Firstly, I think engineers and scientists have to work with governments to see that policies are devised that have a rational basis, that are based on adequate analysis and a clear evaluation of options and their outcomes, And I think what is also critically important is to introduce some degree of training of engineers, perhaps right at the level of basic engineering education, by which one could direct attention to some of the critical challenges that confront these professions in meeting the threat of climate change. And that would apply as much to mitigation as to adaptation measures. In the case of adaptation, I mean, if you take an example like excessive floods, frequent and very severe floods, this would need totally different infrastructure to be able to protect life and property. If you look at the problem of cloud bursts and extreme precipitation events, this would require very different drainage systems. And all of this, I think, could be introduced at the level of basic engineering education, so that at least people who graduate and then enter into professions can focus on some of these problems and possible solutions far more effectively. And I would submit that this is something in which the lead needs to be taken by the engineering professions themselves. And therefore, I find it distinctly an honor to be able to talk to such a distinguished audience. I don't want to create a scare scenario, but I might say that we have been very surprised with some of the facts and the findings that we have come out of the fourth assessment report of the IPCC. And what causes concern is the fact that there is an acceleration not only of changes related to the climate, but also the impacts that are associated with it. And therefore, may I say that there is a sense of urgency that we all need to accept and act on, because only then would we be able to come up with solutions that are timely and effective, and that, as this particular quotation from Gandhi suggests, that will help us move away from deficiencies, distortion, and most importantly, self-deception. Thank you very much.
Ladies and gentlemen, Dr. Pachauri will now be delighted, I know, to take any questions or any statements and provide answers or just listen. So the floor is yours. If you could wait for a microphone, microphone's needed here, and identify yourself and your affiliation, it would help enormously. Sir.
My name is Jim Kennedy. As an octogenarian, I'm no longer affiliated. In the case of China, judging from international fora, the Chinese government itself seems to recognize the impact of climate change and also is prepared to address these impacts through coping strategies. In the case of India, and I raise this with great hesitation because in India, about which you know so much, the engineers and technologists and scientists similarly seem to recognize both the impact and are prepared to address the impact. Whereas, and here I stand to be corrected, judging from international fora, it seems that the Indian government is rather less prepared to address the issue of the impact. I stand to be corrected.
I think what you've said is entirely correct, but I'd like to reassure you that there's a major change that's taking place. And in the last few months, and here again, I can state that I'm an Indian and I've been interacting with every level of the government, trying to highlight the seriousness of this problem. I got a good audience at every stage, but I didn't see much action. What has really made a difference is the release of the IPCC reports. And the Indian government has taken immediate action by setting up two pretty high-level bodies. One is a body that is chaired by the principal scientific advisor to the Indian government, and that's looking at impacts and adaptation strategies. and this includes people from the government as well as those outside. And I expect you would now get a fairly large allocation of resources and efforts to adapt to climate change, because suddenly now there is a deep concern on this. The agriculture minister himself spent 3 hours with us. I took him to our institute, made a presentation, and on the 11th of this month, in fact, there is a conference that has been organized to look at what needs to be done for adaptation to climate change in agriculture. The second committee is one that the Prime Minister has decided to chair himself, and this is called the Prime Minister's Advisory Council on Climate Change. My institute has been asked to prepare a detailed document that will be submitted to this council. They are then going to consider it and then announce their climate change policy. There was recently a survey carried out which found that the highest percentage of people who expressed concern about climate change for some reason exists in India. And I would say, thank God we have a democracy where later rather than sooner, some of this will get translated into action. So all I'd like to highlight is the fact that I think we're on the cusp of a change that's taking place, as indeed I see taking place in China as well. How soon things will happen is a little difficult to predict.
Thank you. Sarah over there. No, in the next in the front here.
Chief Executive of the Royal Aeronautical Society. First of all, I'd like to make an observation on the last question. I think it is tremendously complacent of people in the Western world, having had the advantage of a lot of technology over the last 200 years and been largely responsible for the CO2 emissions that have resulted from that technology, to expect China and India to lead the way in terms of its reduction. I think quite the opposite. I think it's up to us in the Western world to actually lead the changes ourselves and accept the fact that might well be a reduction in economic growth as a result where we live, because I think it is utterly wrong to expect China and India, because in the future they're going to be the main emitters of CO2, to start the process going. The question I'd like to ask you is simply this. Do you believe that this profession, which I hasten to add I'm not a member of myself, should actually, when it looks at priorities, should look at those technologies that are likely to have an effect globally on emissions and not just look in their backyard?
Thank you.
Thank you, sir. I'd say your views are very enlightened, and I couldn't agree with you more, but let me say that to bring about this shift in focus towards those actions and technologies that would have a global impact, one would also need somewhat different institutional arrangements. And my submission is that the time has come to explore research and development opportunities that involve North and South. Because in the past, often what has happened is we've tried to paradrop technologies in the developing world, and some of them have not been suitable. And today I think there is a growing level of capability and expertise in developing countries, and more importantly, the need for looking at very specific local needs. So I think we need to promote and somehow ensure that there's much more collaborative activity, partnering activity between organizations in the North and South. That would ensure that whatever innovations we come up with are used all over the globe. But one last point, if I may make on this issue. I believe very strongly, and I've said this in every forum, even in India, it would be a terrible mistake if we were to emulate the developed countries. And I think we have to find, for local reasons, a very different path of development, because there are huge local impacts in terms of pollution, in terms of depletion of natural resources. And I think without sacrificing economic growth, today's knowledge and technology gives us the capability of defining that path. But it will take a great deal of intellectual and political effort to do that. And I think in that bargain, we would also be helping the global environment. and I hope that will happen. Thank
In
you.
the fourth row from the front, on this side, please. So,
Thank you. A very interesting talk on the anthropogenic effects of the global
could you
warming.
identify yourself, please?
Oh, yes, I'm Anthony Milner, member of Space Guard UK. I'm concerned about Earth in space and the space debris and sky static, etc. Now, I hope in future discussions we mustn't let this subject get carried away with the anthropogenic aspect. Is it possible to have more other scientists who are going to emphasize the astronomical effects upon climate change? You must have some dissenting voices in these discussions, because it does tend to seem to be just a consensus opinion and there's no critical voices at all. Now, I've written books on climate change dating back to the 1980s, and I emphasize the astronomical and the oceanic effects of climate change, and I've got some colleagues and friends who are rather upset about the fact they may not be able to ever publish any more data about the effects of the sun on the Earth's climate. And would it be discredited if anyone came out with new data concerning the astronomical aspects on climate change? Now, one thing that does puzzle me is the statistics in regard to CO2. In my book, I said that CO2 was 0.03% of the total of gases. Now, that is 350 ppm. It was, according to New Scientist, it's getting nowhere near 440 ppm. So we're still, I wrote in 1989, 0.03%. It's still 0.03%. Now, the people don't understand that. Why has it not gone up considerably more? The other aspect is the effect of the oceans on the Earth's climate. There's a danger in working with the wrong model of the Earth. You know, the oceans actually cool down the planet. They don't warm it up. Al Gore was saying Venus's temperature is 845 centigrade, or was it Fahrenheit? But you can't compare Venus with Earth, because Earth is covered 2/3 in ocean. Now, I just mentioned that because this is the standard climatological
I'm going
thing.
to press you for your question, sir.
Well, could we have more dissenting voices on this subject?
Thank you.
Well, I think we welcome dissenting voices, but may I submit with all due respect that all the models that are being run today clearly take into account solar activity, and they can now be very easily identified in terms of the separate impacts that they have on the Earth's climate. And may I also say that what the IPCC produces is the result of the efforts of literally thousands of scientists, and we are open to those who have different views, different scientific capabilities getting involved. And I can assure you there's a great deal of heated debate that takes place when we write our reports, and each of these is also reviewed by a very thorough, transparent and open process. So the dissenting voices are there, but for whatever reason I think the so-called voices of skeptics, in my view, have gone down substantially, and nobody has threatened them, nobody has in any way tried to curb what they want to say. And I can say personally, I welcome people questioning whatever is being done and whatever is being produced by the IPCC.
Thank you. Third row from the front on the end, sir, and then two in the middle here. Sir.
Thank you, Dr. Pachauri. My name is Sribhushan Ghosh. I'm from AT Consultancy and Civil Engineering Consultants here. I graduated from Indian Institute of Technology in 1959. One of the points that you have mentioned, that first of all, the flood and flooding, etc. Having seen the development of the Thames Barrier for prevention of flooding in London, I know for sure that it would be well beyond India or China's means to create a matching constructions. Literally, we are going to suffer the flood. But I do wish you to make some comment on this factor about these solar activities, because there were a number of points have been raised, and in my stay here, during my stay here, I have also known that in England, a cold country, but in the Roman times they used to have vineyards. And they also have pointed out that Hannibal, he had elephants crossing the Alps. So quite clearly, there have been periods of warm climates, and not quite 125,000, but more recent than that. Is it just not an aberration because of the solar activities that we are experiencing this problem? Thank you.
But as I clarified in response to the previous question, today what we have is very comprehensive assessment which can be validated on the basis of past data, where you can separate the impact of solar activity versus the impact of anthropogenic emissions and concentration of these gases. So on that issue, may I assure you there is no doubt. And as for elephants being common in this part of the world, maybe they died out because it was cold for a long time. So I mean, I wouldn't know. I would have to study the history of elephants in different regions of the world to be able to, I suppose wine is still produced in Britain. There are locations where, but maybe in Roman times the Romans were the one who drank all of it. Now we probably have more equitable distribution, so one doesn't get to notice it. So.
Thank you. Again, in this row, please, Sir Mark Moody-Stewart, and then the gentleman behind. No, this row here, please, the same row. Thank you. And then one behind later. Thank you.
Sorry, Mark Moody-Stewart from Anglo-American, a mining company. You very rightly, I think, stressed the need for a carbon price, and I think we're making some progress towards that, carbon pricing and carbon trading systems, which is developing in Europe with faltering steps and missteps, and I think will come in the United States. That requires a framework to create the price of carbon. It seems to me, and I'd welcome your comments on how this might happen, that we have to be able to use that mechanism to transfer capital funds from the developed countries into China and India. That's quite difficult to do politically, but it seems to me to be the only mechanism for actually achieving global agreement. Because if you talk to as I do in my business, to the Chinese, they say clean coal technologies we're happy with, but when it comes to sequestration, you want it, you pay for it, basically. So we have to find a mechanism. Have you some suggestions as to how that might be done politically?
I would agree with you entirely, Sir Mark, that you need to find market solutions. I mean, those markets can be created through regulation. One of the major benefits of the Kyoto Protocol, which is not highlighted enough, is the fact that it's created a market for carbon, albeit a very small market and quite inadequate. But this is the result essentially of course, the fact that we have these so-called flexible mechanisms. My own view is that in the next commitment period of the Kyoto Protocol, there'll have to be a substantially larger role for these mechanisms so that there is a movement of capital and technology from north to south and perhaps even between south and south that would address the problem of emissions of greenhouse gases. And I personally feel, complex as it is, that globally we'll also have to agree on some norms by which carbon is priced. Whether it's in the nature of taxes that are agreed on by everyone or some level of taxation or other measures. But the urgency of the situation and the efficacy of market-based solutions requires that we have a price on carbon. And to me, that seems to be the most effective way by which we move to a low-carbon economy. To be quite honest, I'm not too sure what's going to happen as a result of the current process of negotiations, but there is seemingly an acceptance of the fact that we'll have to place a price on carbon, and therefore the next agreement will certainly have some degree of movement in that direction.
Thank you, sir. Thank you, sir, with the microphone.
Anthony Derbyshire, Environment Fellow of the Commonwealth Foundation. In your figures, you make the statement that 26% of greenhouse gases come from energy. You also make another statement that another fairly high percentage comes from buildings. And of course, industry also produces some. Could I make the observation that a large proportion of what comes from buildings and industry actually comes from energy generation?
Sure, absolutely.
Now, it would have helped me if in your published figures, if you had actually made a statement of the proportion that comes from energy. The observation I would make is that energy generation comes from a finite number of plants, big plants that you can see across the world. All other emissions come from an almost infinite number of sources. And therefore, if there could be a focus on the energy production, which we have the technology to maybe abate fairly quickly, that might accelerate the abatement.
You're absolutely right, sir. What I had presented was really a summarized form of the data that we have. But we, in the Working Group 3 report, we have clearly shown the sources in great detail. And you're entirely correct in saying that, after all, even in buildings, the emissions really come from the use of energy. And to some extent, or to a large extent, you can attribute that to the entire energy production cycle. All that is available in considerable detail in our Working Group 3 report. If you want, you could go to the website of the IPCC, and if you look at the Working Group 3 report, you'll be able to get all that information directly.
Thank you, sir.
Hi there. My name is Jonathan Leake, and I'm the Science and Environment Editor for the Sunday Times. As I'm a journalist, and as we're about to have an election, almost certainly, this is a slightly political question. So a couple of points, first of all. Back in 96, 97, the Labour Party, which is now in government, produced a document called In Trust for Tomorrow, which set out an environmental manifesto that focused a great deal on climate change. And then they came to power, and as the years went by, the promises they'd made gradually failed to materialise. And by the time we came to the 2001 election, the the environmental promises in the manifesto had shrunk to about half a page. And again, we saw not that much delivered. And by 2005, when we had the last election, climate change had been reduced to 2 paragraphs, sandwiched between the national lottery and the Olympics. Now, over that period, we've also seen Britain's CO2 emissions rising, albeit not as much as many other countries. We've seen the carbon emitted from a power sector rising, and we've seen our renewables. I think we're bottom of the European League for renewable energy. So, without asking you to be party political, and without asking you to say anything about Labour or Conservatives, and just by the way, the Conservatives have produced their own similar document just recently, and I've just come back from Blackpool, where a number of our Conservative delegates were saying things like, we don't want any more of this green rubbish. We want some core policies, please. And you can see them going the same way as Labour. So not asking you to specify anything about the parties in particular, what message would you have as we enter what is probably going to be an election period for Britain's politicians and how they should deal with climate change?
Well, I wouldn't isolate any country in concluding that the world has not done enough. And I don't think Britain stands alone in this inadequacy of actions. What I would say is that ultimately it's the people who have to raise their level of awareness, and I'm very grateful that you're present over here, because I think the media has done a tremendous job in the last few months in educating the public. And in a democracy, in the ultimate analysis, that's the only thing that's going to work. If the people demand a set of actions on a subject like climate change, the leaders are smart enough to realize that it's in their own interest to respond to that demand. And I'll end by just giving you one example. I was in Australia about 2 months ago. My God, the extent to which climate change has entered the political agenda is something that you couldn't have predicted 5 years ago. And that's the result of perceptions about the droughts, the continuous droughts for 6 years, and everything else related to climate change. It's just an explosion of awareness and understanding which is forcing political parties that have resisted any action to that direction. So I would only plead with you to keep up the good work, and you'll probably get the right decisions on the part of political parties.
Thank you very much. I have a problem. We have about 8 minutes. We have at least 16 questions to go. It's not possible to do this. I'm going to ask people, please, to limit their question to the core of the question to give Pachauri a chance to answer them. Sir, in the 7th row. Please.
And I'll try to be equally brief.
Andy Hopper, University of Cambridge Computer Laboratory. I'm on the technology development and collaboration angle, and my question is, do you, as I do, feel that the legal frameworks, the patent frameworks inhibit or may inhibit some of the very urgent innovation that needs to take place? And have you a suggestion for what institutions like the Royal Academy can do, for example, in the way of model contracts or in the way of agreeing to collaborate with others and encourage faster innovation by reducing some of these barriers?
I think that's a very relevant question. My own belief is that today in most countries in the world, you have in place patent laws and issues related to intellectual property firmly in place, by which I think one can go ahead with healthy collaborative arrangements and contract research and so on. I'm really not in a position to say whether this is true uniformly across the globe, but certainly I think a body like the Royal Academy could help to shed light on some of these issues, maybe commission a study or something that might show the way. So I would say that's a good suggestion, and much can be done then.
Thank you. The 5th row, I think.
Brian Legg, a trustee of Rothamsted Research, which is an agricultural research station. If you look at a realistic estimate of renewable energy potential on a global scale, how close can you get to our current and predicted future energy use?
I think an area where perhaps a breakthrough is possible and will probably take place is in the conversion of cellulosic material to perhaps liquid fuels. Now, if something like that was to happen, you really get a large chunk of fuel supply from agricultural residue, other forms of biomass. I think we are not utilizing solar energy as effectively as we should, and innovation over there can make a difference. Wind is another. I think you really need a whole range of innovations, but all of this will happen if there's a price on carbon. If you don't have that, then it's not going to get anywhere.
4th row here, please.
Mine's very quick. Langhorne, a consultant. I attended the 4th assessment meeting at the Royal Society, and during the course of this 2-day meeting, there was no mention whatsoever of methane hydrates. I raised this question to be told that it wasn't actually an issue. Can I recommend that perhaps IPCC should set up a working group or a subgroup or a panel just to address this issue, because it could be important?
Sorry, did you say hydrates?
Methane hydrates.
Methane hydrates. No, in the working group 3 report, we have covered methane hydrates. But I agree with you, this is a technology that perhaps needs much greater attention. We'll probably deal with it in a special report that the IPCC is likely to take in hand very soon. Thank you.
5th row, John Ahmed. This side.
John Ahmed, Chairman of the Olympic Delivery Authority. I I really wanted to come back to this point about government intervention and carbon pricing. Alan Greenspan, in an interview a couple of evenings ago, made the point, really almost in, I suppose, supporting Gandhi, that in fact if you look at what's happened in economies, then it has been driven largely by people and governments' behaviours, which, as he said, have largely been behaviours driven by deficiency, deception, and what was the other one, self-deception. Can you say why you think we can be more optimistic with this issue than we should be after 100 years of governments trying to influence economics and generally failing?
My simple answer, and it may be a simple-minded answer, is that there's much greater information available. And I think one can go to the internet, one can go to several sources which were just not available 10 or 15 years ago. So I think there's a major change taking place over there. And perhaps in the future you would find civil society and those who can influence decisions much better informed to be able to bring about the kind of shift that is desired. Now, this may be naive, but my belief is that something like that is happening and will make a difference.
Thank you. There's a lady on the end here, madam, on the fifth row. That's right at the end, please. No, right at the end.
Zoe Spriggins, DEFRA. This is a question in the context of the Washington summit and certain countries' concerns about sovereignty. Do you think that legally binding emission limits for every country are necessary to tackle climate change?
My belief is you'll need a mix of measures and a mix of policies. And as I said, in the case of legally binding measures, as we've seen in the case of the first commitment period of the Kyoto Protocol, it's achieved a lot. I mean, one can easily decry what's happened under the Kyoto Protocol. But firstly, the fact that so many countries together agreed on a set of measures is really unprecedented and of historic importance. Secondly, the fact that this has led to an examination of the means and policies by which governments can achieve these targets in itself is a huge intellectual resource for that society and gives you a lot of information. And thirdly, as I said earlier, the development of a carbon market. I think all of these have been important, but perhaps the next commitment period will have a wider mix of policies.
Ladies and gentlemen, I think we've run out of time. What I would like to do on your behalf is to thank Pachi for being here and giving us his time this evening. I think the questions went across the range of things that we could have noted and inquired upon. I do think, if I may add one personal comment, that I've never believed that markets are natural. They're always set up by those who wish to create some forward motion or some backward motion. Markets for the climate are no different. We just have to, I think, remember that there's a difference between markets that are designed to utilize what we know and markets which are designed to create something that we don't know. I believe that the work of the IPCC gives us a great foundation upon which to go forward. It's been a great privilege to have the chairman of all this work with us this evening. Thank you for coming. Thank you for giving us your time. Thank you very much.